Hi there, my name is Oster, and in this tutorial I'm going to show you how to build this little HDA here. It has a couple of controls. The first one will give you the ability to add or remove spheres, and the second one controls the radius of those spheres so that as you add more you can prevent them from intersecting quite as much. And the magical part of this is as you add or remove these little spheres, the RGB values will be recalculated so that we can preserve this lovely rainbow coloration that we have. So let's go ahead and turn off this subnet, and we'll add a new one to begin rebuilding. And inside that subnet, I will add a geonode, and inside that, I'm going to add a sphere. So I need to repeat a series of steps on the sphere, so I'm going to add a for loop, and the one I'm looking for here is for each number. And I'm just going to plug the sphere directly in to the input. And before we get too much farther with the for loop, there's some important information, which is that the number of times I've passed through the for loop is kind of operative, and that data is stored in my for each count node here. So if I select it, you can see in the geometry spreadsheet, in the detail tab here, I have iteration, I-value, num-iterations, and the value. And so iteration is going to be like, which pass have I made? Like, which pass am I currently on? What are the total number of passes? This one starts at 1. Same deal here, num iterations. I don't really know what the difference is between I-value and num iterations, to be honest, but iteration is the kind of the important thing that we're going to need to get. And again, it lives in the for each underscore count 1 in the detail attributes. So that'll make more sense shortly why that's important. I'm going to go ahead and add a transform. And I'm going to actually do a better job connecting it. There we go. Okay, so in this transform, let me go ahead and unpin my controls for the original HDA. The first thing I want to do with this little sphere here, and I'm going to be doing this to each sphere that passes through. So the first thing is we will move it 10 units off of the origin. And if I activate that, you can see now it's hopped over 10 units. And then I'm going to move the pivot back to where it was. So if I turn on the pivot, you can see now that is sitting over there. And then the next thing I want to do is I want to add some rotation. So you can see here in my rotate under the Y, if I start increasing this value, we're going to begin moving around the circle. It's a hypothetical circle. It doesn't exist yet, but will shortly. And each sphere that I create needs to be progressively moved around that circle. So what I'm going to do is I'm going to write a little expression, and I'm going to use what is called a detail expression. Because again, what we kind of want to get is the for each counts detail attribute. If I click on that, we can see that's going to be here, and I'm going to be looking for the iteration attribute on that. So the expression is going to be detail, and then parentheses, and what I want to do is I want to tell it which node that I'm interested in grabbing that detail off of. So as I begin typing, it'll say, perhaps you mean the for each counts that are here in the same little layer. And then I'm going to tell it which one I want, which is iteration. And then there's one more argument that it takes, which is going to be, in this case, just a 0. I think it's if the detail data is an array, this will tell you which element of the array. But because it's just a single value, I think it just wants this sort of default value there. And then if I just have the same number, this will be like 1, 2, 3, 4, 5, 6, depending on which iteration through the for loop I happen to be on. This is barely going to budge. What I need to do is I need to multiply it by a larger number so that I can see that rotation occurring. And there we go. That's kind of what it looks like. But I want to go all the way around the circle. So what I need to do is hop over to my for each end. I'm going to increase my iteration value to 72. And you may have noticed that I used 5 here in my expression, and 72 times 5 equals 360, so we get our lovely little circle here. So before we go too much further, I'm just going to hop over to the uniform scale, and we'll reduce this down so that we can eliminate some of that interpenetration and see what we are doing with our colors, which we will tackle now. All right, so before we could begin calculating our RGB values, we need to just very briefly review something about sine waves. So as we take the sine value of these degrees that we get as we travel around the circle here, we're going to generate this curve. So if you imagine this is 0 degrees, the sine of 0 is going to be 0, the sine of 90 is 1, the sine of 180 is 0, and the sine of 270 is -1, and the sine of 360 is back to 0. So that's how we can generate this curve as we feed in whatever degree we happen to be on as we travel around the circle. And then it doesn't matter how big those numbers get, we just crank out the same exact curve over and over again forever. You can see here as we go up in value, we're just cranking out the same 0 to 1 to 0 to -1 curve forever and ever and ever. So what we're looking for here is individual values for the red channel, the green channel, and the blue channel. And it just so happens to be that for the red channel, we're just going to use the actual sine value as we go. And then for the green channel, we're going to take that exact same curve and we're going to offset it by 1/3. And then for the blue channel, we're basically just going to offset it by 2/3. So if you're looking at whatever the values here are for the red, green, and blue, that is going to give us that nice rainbow color. Now you may notice that we've got some negative values here. So we need to rescale the curve so that it goes between 0 and 1. Rather than 1 and -1. So there's a very simple way that we can do that using Houdini here, and I'll show you that in just a second. So, but I just wanted to sort of clarify before we jump in what's going on with the curves that we're going to be creating, and then how we're going to be kind of modifying them and then feeding them into our RGB values. All right, so now that the sine wave conversation is out of the way, it should be apparent why I need to get the specific rotation of each sphere, and I can't make assumptions about how many spheres I'm going to end up with. So here is what the formula for that looks like. So the rotation value, which is what we will be feeding into our sine function down the road, is basically equal to whatever the current iteration value is. So like for instance, if I am on the 10th sphere, the iteration will be 10, and I want to multiply that times 360 divided by the total number of iterations. So 360 is obviously the number of degrees in the sphere, and the total number of iterations is the total number of spheres I'm ultimately going to make. So here's a practical example. If I'm on the 10th sphere out of 100 total spheres, that's going to be 10 times 360 divided by 100 will equal 36 degrees. So for my 10th sphere, the value that I'm going to be feeding into the sine function is going to be 36. So we need to figure out, in order to make this work, the current iteration and the number of total iterations. So in order to get that information, oh, there's one more thing worth mentioning, which is that we are about to dive into some vecs. What we used before in our little transform here, this is an expression, but we're about to use a point wrangle, which is going to be vex, which requires a slightly different way to input the information. So with the expression, the detail expression, I was able to just reference the surface node directly and then tell it which attribute I want to get, and then what the index of the attribute I was interested in, which is 0. But if I'm using a vex function, I need to use this geometry. So what this basically means is the geometry is whatever's getting directly piped through my little for loop here. So if I want to have access to this information, I need to use an attribute transfer in order to get that into the geometry stream. So I'm just going to go ahead and add one of those. Attribute transfer. And then we'll just plug our little for each node directly into that second input. And then if I click it, I need to just activate detail. Now, if I don't specify which detail I want, it'll go ahead and just pipe them all in. And you can see here they all are. So if I picked one, like an iteration, for instance, it'll only pass that one through. But I want iteration and num iteration. So in this case, it makes sense to just use the whole thing. And then I need to add a point wrangle so that I can begin to grab that data and do stuff with it. So to begin, I need to get my iteration. So I'm going to say it's an int because it is a whole number. Iteration equals detail. And in this case, rather than referring to a specific node, we're actually referring to the index of the input that we want to look at. In that case, that's going to be the first index, which we refer to with a 0. And then let me make sure I'm spelling it correctly. And we need to put a semicolon because it is vex. And then I am going to create another variable here called num iterations. And we'll set that to something very similar. Use the first input. The attribute that we want to get is num iterations. And the array is 0. Array index, I mean. And just to make sure that this is working as we expect, let's go ahead and print it. And the formatting on this is standard issue if you're familiar with a lot of languages, but I'm coming from Python. I think this is all sort of derived from C. And then we want to use iteration here. And a semicolon. Oh, and I need to put a new line character. And then we'll just do that same thing. Add in the new line. And a semicolon. And right now I'm running over points. I need to set this to primitives, I think, although it may not actually matter. But you can see here, we're getting the same value for num iterations for every single time we pass through the for loop, but we're getting an updated value on our iteration value itself. So let's go ahead and make a new variable. We'll call this one rotation. And I'm going to make this a float. And we will set this one equal to iteration times 360 divided by num iterations. And let's go ahead and print that value as well. And I think we need to use %f because it is a float value. Throw the new line character in, and then don't forget to break the string. And we come over here and we can see we are now getting our rotation value, which is looking pretty good. Okay, wonderful. All right, so now we've got our rotation value for each sphere, which is going to be fed into the sine function, but there's an important thing to note about the sine function, which is that it is expecting the value that it is calculating to be converted into radians. So we need to do that before we can get the proper sine value. So the way we're going to do that is we'll just start over here. First of all, I think I'm going to go ahead and comment out some of these print statements. We may decide that we want to confirm some data later on, so I won't clear them out just quite yet. So I'm going to begin by making a variable called float r, and we will set it to initially, just to keep it nice and simple, rotation. So rotation again is going to be just whatever the degrees are. So the first thing that we need to do with rotation is we need to convert it to radians, and the easy way to do that is you just, well, it'll help if you spell it right, radians, and you can see it turns this this other color, this teal color, so that we know that we've got the reserved word there. And then once it's converted into radians, that's where we can go ahead and grab the sine. So I'm going to go ahead and just for laughs, I'm going to go and print this out so we can take a look at what r looks like. Right, make sure you put that semicolon in there. So we got this little red line there, and that basically means there was a problem with it. So we'll just hop back over, kind of recalculate it. And if I take a look at my printout, now we can see we're getting what we expected here, which was a whole bunch of decimal point numbers. Some of them are positive and some of them are negative. My guess is it's pretty much a 50-50 split. And we need to fit this curve into a different range. We want everything to be in 0 to 1. So we're going to use a simple fit function. So I'll hop back over here and I am going to just say fit. And so the way fit works is you need to tell it the current range, current min, current max, new min, and new max. It's pretty awesome. And we'll just go ahead and run it again. And now we can see our output is all, well, let me clear it and we'll run it again. All right, so here we can see everybody is positive. So that's going to be our R value. And as I mentioned before, what we need to do for the green and blue channels is we just need to basically offset the curve by 1/3. So the way I like to do that is by just adding, for our green channel, we will add 120 degrees to our current rotation. And for our blue channel, we will add 240. And we can comment out this print statement. And then I am just going to use at cd.r, set it equal to r. And at cd.g, set that equal to g. And for the blue value, we'll just set that equal to blue. And there you go. There our colors are being recalculated. So now we're going to go ahead and modify the HDA so that we can expose this value and also the sphere radius value to the user. All right, so we're going to hop over to our subnet, right click on it, hit create digital asset. And we're going to get this type properties editor. I'm going to go to parameters and we'll just go ahead and make all of these things invisible. And we will, let's see, hop in. And then, so for sphere radius, that's going to be uniform scale. And I'm just going to go ahead and rename this sphere radius. And we can keep the scale too. Doesn't really matter. There isn't too much going on. I think I probably need to make that invisible as well. And then I also need to come down to my for each, and I need to expose my iterations. And I'm going to call this number of spheres. And hit apply. So now if I hop out to this subnet, go in there, we can see we now have the number of spheres and the sphere radius, but there's one more thing that I'm going to need to do, which is we used this this hard-coded value of 5, which is going to be our degrees, and we don't actually want to do that. We need to make sure that we are calculating the total number of spheres properly and then figuring out the correct degree count. So what we need to do, I'm going to go ahead and just hit Control E here so we get a little bit of a better view, is rather than using 5, what we're going to do is we're going to actually grab the num iterations. And we'll hit apply. So now we're recalculating as we rotate so that we should be able to maintain a consistent spacing here as we go around. Otherwise it would be locked at 5. So, and also, well, let's just try it and see if it works. All right, so we're recalculating our angle and our RGB value looks good, but our number of spheres, obviously we're going to want more than 10. So let me just go back up to my subnet. We'll right click, go to type properties, and we'll go to the parameters. What am I missing here? Sorry, it looks like I converted my geo into an HDA rather than the subnet, which I did not mean to do, but it isn't a big deal. Won't change what's going on here. But let's see, so I've got my number of spheres, and I want to change my range to, oh, I don't know, let's say what, like 100 or something. And we'll hit apply, and we can close this. And so now you can see we are recalculating the spacing and the RGB values of our spheres, and if I change the radius, that is all working as well. So there you go. Hopefully this has been useful. A little dive into some expressions and some vects, and we make a pretty rainbow ring of spheres along the way. So if you have any questions, feel free to shoot me an email or leave it in the comment section. I'll do my best to get you sorted. Thank you very much.